Venice built one of the most expensive flood defenses on Earth, 78 steel gates, over $6 billion. By the numbers, it works. By early 2026, it had been raised roughly 150 times, keeping the city dry when the Adriatic tried to take it back. But just 5 years into service, engineers are already sketching a plan B. Not because the barrier failed, but the sea didn't stop rising just because Venice built a wall. The barrier is already being raised far more often than its designers originally expected. Scientists warn that if this keeps up, Venice could lose its lagoon entirely. So did this city build a masterpiece, or the most expensive pause in engineering history? Venice has flooded for centuries. Aqua Alta, the seasonal high tide, is practically part of the culture. But in 1966, a record tide of 194 centimeters inundated much of the historic city, bringing tourism to a standstill and damaging thousands of historic buildings and priceless works of art. That flood turned a nuisance into a national emergency. Part of the problem was Venice's own weight. Decades of industrial groundwater pumping on the mainland had quietly sunk parts of the city, so every tide had less cities standing above it. The proposed fix sounded almost fantastical. Dozens of hollow steel gates lying flat on the seabed, invisible until the moment they were needed, engineered to disappear rather than stand as a permanent wall across the lagoon's mouth. It took 37 years just to break ground in 2003. It took another 17 after that, before the system, called MOSE, finally went live in 2020. On paper, MOSE was elegant. Instead of trapping the beautiful city behind a permanent wall, engineers designed gates that would vanish for most of the time. Across 3 inlets, 78 gates would sit hidden on the seabed. Ships would pass, and tides would flow, untouched. Only when a genuinely dangerous tide approached would compressed air push the water out of the gates, letting buoyancy lift them into a temporary wall against the Adriatic. Each gate was engineered to swing upright inside 30 minutes once forecasters flagged a dangerous tide. The ambition matched the stakes. Venice is a UNESCO World Heritage Site, holding irreplaceable art and architecture. The famous St. Marco Square, the lowest point in the city, is almost never empty. Even when it's flooded, tourists still crowd in, wading through ankle-deep water for photos. If MOSE worked, this could change, and MOSE could become the template for coastal defense everywhere sea levels were climbing. The price climbed too, from an original estimate near $2 billion to more than $6 billion. Supporters argued losing Venice would cost far more, and at the time, few saw a real alternative. Nobody imagined the biggest threat to the project wouldn't come from the water at all. And then, in 2014, it came from a courtroom. Italian police arrested Venice's mayor, Giorgio Orsoni, along with roughly 3 dozen officials and executives, over a bribery scheme built into MOSE's construction. Investigators alleged tens of millions of euros had been funneled into foreign accounts to buy political favor over more than a decade. Despite the scandal, construction continued. The system was built to intervene only in genuinely dangerous conditions, roughly 1.3 meters above normal sea level, so routine high water would still flow into the lowest streets by design. Then, MOSE finally faced a real test in October 2020. All 78 gates rose and held against a 1.5 meter tide outside the lagoon. St. Mark's Square stayed dry while the sea piled up outside. Mayor Luigi Brugnaro stood before cameras and said simply, "Today, everything is dry. We stopped the sea." That wasn't a one-time win. So, was $6 billion wasted? On performance alone? No. But then the smaller problems started surfacing. Corrosion on the steel hinges, erosion reshaping the seabed beneath the gates, repairs nobody had fully budgeted for when the system was first approved, and a question nobody wanted to ask out loud. If the barrier is working, why are engineers already worried? Some scientists have put it more starkly. Keep this up, and Venice risks losing its lagoon entirely. To understand the worry, you need to understand what MOSE asks of steel and saltwater every time it moves. Picture 78 enormous trapdoors resting flat on the seabed, invisible most of the year. When a dangerous tide is forecast, compressed air forces water out of each hollow gate. The gates turn buoyant, rotate upward on their hinges, and lock into a wall. When the danger passes, the air releases, water floods back in, and the gates sink out of sight again. The concept is simple. Running it for years is not. Every rotation puts enormous load through steel hinges sitting in salt water, and salt water plus repeated movement is a corrosion problem almost by definition. Some components wore faster than the original design accounted for, and engineers had to retrofit reinforced hinges and rethink maintenance schedules that assumed far less frequent use. The seabed adds its own complications too. Shifting currents erode the sand around the gate foundations, so crews have to monitor and reinforce them over time. Then there's the cost that doesn't show up in a headline number. Building MOSE was the beginning, not the end. Each activation cost hundreds of thousands of euros in staffing, energy, and disrupted shipping. During the 2026 Venice Carnival alone, the barriers were raised 26 times in just 3 weeks, costing the city more than 5 million euros. Every closure also seals the lagoon off from the open sea, cutting the natural exchange of oxygen and sediment that keeps the ecosystem alive. Scientists studying the lagoon warn that frequent closures could reduce the sediment transport that helps sustain its salt marshes, the same marshes that quietly help hold the sea back. But corrosion can be repaired. Hinges can be replaced. The one thing MOSE cannot fix is the ocean itself. That's where this turns into a countdown. MOSE was designed around exceptional floods, activated only a handful of times each year. But rising seas are already forcing the barriers to close far more often than engineers originally expected. Alvise Papa, who runs Venice's tide monitoring center, has warned that within about 3 decades, the city may need to raise the barrier daily. According to lagoon scientist Andrea Rinaldo, who leads the scientific committee, that could mean roughly 200 closures a year. At that frequency, he warns, the lagoon stops exchanging water with the sea at all. As Rinaldo put it, you won't have a lagoon. And without the lagoon, you won't have a city built to sit inside one. That's the arithmetic behind Venice's emerging Plan B, now under open discussion barely 5 years after MOSE went live. A 2026 study modeling every adaptation option for Venice reached the same conclusion. No available path preserves the city exactly as it is today. Nobody is claiming the barrier failed. They're admitting it was built for sea level assumptions that are already beginning to change. And the version coming next may need something MOSE was never designed to be. Behind all of it still sits the corruption scandal, a reminder that even celebrated engineering can become entangled in corruption. The lesson stretches past Venice. A mega project doesn't end when the ribbon is cut. Sometimes that's exactly when the harder decisions and the harder bills really start. So, did Venice waste $6 billion on a doomed defense? Not exactly. The barrier has already done its job roughly 150 times, keeping a city older than most nations from drowning on schedule, corruption scandals included. MOSE wasn't a total failure. It may be better described as an extremely expensive breather, one bought for $6 billion, with a meter still running every time the gates rise. Did Venice save itself? Or did it just buy the time to figure out how?